right, so today we're going deep on deep learning.
Oh, yeah.
But not the feel-good kind. It's more like
No.
the kind that keeps you up at night.
Yeah,
You're talking vulnerabilities.
Yeah.
The cracks in the system,
Right.
the things that can be exploited.
Huh?
Think self-driving cars, misreading signs, or spam filters, letting everything through.
It's unsettling stuff.
And you've been deep in this research.
I have, yeah.
And I've got to say, some of it is straight up unsettling.
Well, yeah, that's the thing about deep learning,
Yeah.
It's powerful, but it's got these quirks, these blind spots, and we're only just beginning to understand them.
Yeah.
And the really unsettling part is that those quirks can be exploited.
Okay, so before we get into the how of all of this,
Sure.
can we do a super quick deep learning 101?
Absolutely.
Just a refresher, so we're all on the same page.
Yeah, great idea.
Yeah.
So, imagine a deep neural network,
Oh,
or DNN,
DNN.
like a super complex function. You feed it an input,
Okay.
like say a picture of a cat,
Right.
and it spits out an output.
Okay.
Like, yep, that's definitely a cat.
Yeah.
And the deep part comes from layers upon layers of these interconnected nodes.
Okay.
Almost like a digital brain.
Okay.
Each node does its own little calculation, and together they learn to spot patterns.
And the paper we're looking at uses a simplified model,
Yes.
a multi-layer perceptron,
Exactly.
to illustrate this.
Yeah.
It's like a mini DNN, right?
Think of it like a simple assembly line.
Okay.
The input layer is where the raw materials come in. Then the hidden layer is where the real work happens, transforming those materials.
Right.
And finally, the output layer spits out the finished product, the classification.
So these DNNs learn from the data they're fed.
Yeah.
And get really good at predicting. But the catch is they're trained on a limited amount of data.
Right.
Does that create a vulnerability?
That's exactly where the adversary comes in.
Oh.
These adversarial samples, as they're called,
Okay.
are like carefully crafted inputs designed to exploit those limitations.
Gotcha.
Think of it like an optical illusion. But for AI...
Okay, that's where it gets really interesting.
Yeah.
So tell me about these attacks.
Oh, okay.
What are the different flavors?
Okay, so let's say you've got a spam filter.
Yeah.
A confidence reduction attack would make the filter less sure about whether an email is spam.
Okay.
Potentially letting some junk slip through.
Sneaky.
It doesn't even have to be malicious.
Right.
Even a poorly designed marketing email could trigger this.
Right.
Yeah.
And then there's misclassification, where the DNN just flat out gets it wrong.
Right. Like labeling a picture of a dog as a cat.
Yeah.
It's annoying.
Right.
But potentially harmless.
But then it gets kind of scary with targeted misclassification, right?
Yeah.
Like forcing the DNN to give a specific wrong answer.
Exactly. Imagine someone manipulating a content moderation system to flag a harmless post as inappropriate.
Right.
Or even worse, letting something truly harmful slip through because it's been mislabeled as safe.
Okay, that's seriously messed up.
Yeah.
And then there's source target misclassification.
Right.
Which sounds even more precise.
That's where the attacker takes an existing input, like an image,
okay.
and tweaks it just slightly. So it's misclassified as something else entirely.
Yeah.
What's fascinating is that the researchers found a way to do this by changing only a tiny fraction of the input.
And they actually tested this on image recognition.
Yes.
Using handwritten digits, right?
Right. Using the MNES dataset.
MFS dataset?
Think classic handwritten numbers from 0 to 9.
Okay.
They could take a picture of, say, a 7.
Okay.
Make a few tiny changes that we humans wouldn't even notice.
Right.
And bam.
Yeah.
The DNN confidently calls it a 3.
Okay, that's where my mind starts to melt a little.
Yeah.
How is that even possible?
It's less about magic and more about math. They use this thing called the forward derivative.
Okay.
Don't get too hung up on the name.
Yeah.
But essentially, it allows the attacker to understand how tweaking the input affects the output.
Right.
It's like having a cheat sheet
Okay.
for fooling the AI.
So they're basically reverse engineering the AI's decision-making process.
Precisely.
Wow.
They use this forward derivative to create these things called adversarial saliency maps.
Okay.
Which basically highlight the most important parts of the image for classification.
So it's like a heat map showing them exactly which pixels to mess with.
You got it.
Yeah.
And get this.
Okay.
Using these techniques, they were able to misclassify over 97% of the images they tested.
97%.
Yeah.
So basically, this is a huge vulnerability.
Yeah, it's pretty significant.
And they did this by only changing a tiny fraction of the pixels.
On average, only about 4%.
Wow.
They tried 2 strategies,
Okay.
making certain pixels brighter
Right.
and making others darker.
Okay.
Both worked incredibly well.
Okay, now I'm thinking, does this mean all digits are equally vulnerable?
That's a great question.
Is it just as easy to turn a 1 into a 9 as it is to turn a 5 into a 6?
Turns out it's not that simple.
Okay.
They introduced this concept of hardness.
Right.
Basically, how difficult it is to craft an adversarial sample for a specific digit pair.
So some combinations are naturally more resistant to manipulation.
Think of it like this.
Okay.
Tricking an AI into thinking a 3 is an 8
Right.
is much easier than tricking it into thinking a 7 is a 1.
Okay.
Some digit combinations are just naturally more distinct.
So this hardness is like a measure of how easily an AI can be fooled,
Right.
depending on the specific task.
Exactly. And
Right.
understanding this hardness is crucial.
Yeah.
Because it shows us which parts of the AI might need extra protection.
Okay. Yeah,
Right.
that makes sense.
Yeah. It gets even more interesting. They actually came up with a way to predict this hardness
Oh,
before even trying to craft an adversarial sample. They call it adversarial distance.
Adversarial distance.
Which is like a measure of how far a sample is from being misclassified.
So if a sample has a high adversarial distance,
Right.
it's less likely to be tricked.
Precisely. It's like having a sneak peek into the AI's weaknesses.
Okay, so we know these vulnerabilities exist.
Uh-huh.
What can we do about it? Are researchers exploring ways to defend against these attacks?
Absolutely. One approach is like setting up a security checkpoint for AI, trying to detect these adversarial samples before they can do any damage.
So kind of like a digital bouncer keeping the troublemakers out?
Exactly. The paper mentions some detection mechanisms,
Okay.
like looking for subtle distortions in the data that might suggest an attack.
Yeah.
For example, they noticed that adversarial samples for handwritten digits tend to have a higher level of noise compared to normal ones.
So it's like looking for those telltale signs that something's not quite right.
Right.
Even if it's not immediately obvious to the human eye.
Yeah. Exactly. But the challenge is making those detection methods robust enough to work across different types of data and attacks.
Yeah, because I imagine attackers are always finding new and creative ways to fool these systems.
Absolutely. It's like a game of cat and mouse.
So besides detection, are there other ways to make these DNNs tougher?
Yes.
More resistant to these adversarial samples?
There is another really fascinating approach.
Okay.
Using adversarial samples during training.
Wait, so you're saying expose the AI to these attacks?
Yeah.
So it can learn to defend against them. It's like giving it a vaccine.
That's the idea. Introduce the DNN to these adversarial examples.
Right.
And it can learn to recognize and resist them in the wild.
That's a really cool concept, and it actually worked.
It did when they trained DNNs with a mix of normal and adversarial samples.
Okay.
They were much more robust to attacks later on.
So they kind of develop a stronger immune system.
Exactly.
This whole thing really highlights the importance of collaboration between security researchers and the folks developing AI. You need both sides to make this stuff work safely.
Right. Absolutely. It's a team effort, and one that's becoming increasingly critical as AI gets more sophisticated and integrated into our lives.
You know, for me, one of the big takeaways from all this is that AI, for all its hype, is still in its early days. We're still figuring out how this stuff really works and how to make it safe.
I agree. It's important to remember that AI isn't magic.
Right.
It's a tool. And like any tool, it has limitations.
Yeah.
And those limitations can be exploited.
Right. We can't just blindly trust these systems no matter how impressive they seem.
Exactly. We need to approach AI with a healthy dose of skepticism.
Yeah.
Always questioning its outputs and looking for potential biases or weaknesses.
And that brings up a bigger point. This isn't just a technical problem.
Right.
It's a societal one.
It is.
If we can't trust these systems to make accurate and reliable decisions, how can we integrate them into things like healthcare, transportation, finance? The stakes are high.
You're hitting on a crucial point. This research really forces us to confront some deep questions about trust and the limits of our own perception. I mean, we're talking about systems that can be fooled in ways that we can't even comprehend.
Right. It makes you question what it even means for a machine to understand something.
Yeah.
If it can be so easily manipulated.
And it raises questions about what role trust plays in a world
Yeah.
where AI is becoming so prevalent.
Right.
If people lose faith in AI because of security issues, it could set the whole field back years.
It's like building a house of cards, one strong gust of wind, and the whole thing could crumble.
That's a great analogy.
Yeah.
We need to be open about the limitations of AI.
Right.
And have clear ways to address vulnerabilities and hold people accountable when things go wrong.
You know, hearing all this, I can't help but think of that famous quote by Arthur C. Clarke.
What's that?
Any sufficiently advanced technology is indistinguishable from magic.
It's a great comparison. There's a temptation to see AI as this magical force that can solve any problem. But in reality, it's a tool that can be used for good or bad.
Right.
And we have a responsibility to use it wisely.
Right. We need to be realistic about what AI can and can't do and be proactive about addressing its vulnerabilities.
Absolutely.
Because as with any new technology, there will be unintended consequences.
Absolutely. The more we understand about how these systems work, the better equipped we'll be to manage those risks.
Okay, I want to touch on one more thing the paper mentioned.
Sure.
This idea of universal approximation. What is that, and how does it relate to all this?
Yes. It's a fascinating concept.
Yeah.
Basically, the universal approximation theorem says that even a relatively simple neural network can learn to do incredibly complex things given enough data and training.
So theoretically, any problem that can be solved with a computer program could be solved with a neural network.
In theory, yes. It's one of the reasons why deep learning has been so successful.
But how does this relate to adversarial samples and making AI more secure?
The researchers suggest that this ability to approximate any function could actually be the key to making DNNs more robust.
So we can train these networks well enough. They should, in theory, be able to resist these adversarial manipulations.
Exactly, because if a network can learn to do practically anything, it should be able to learn how to defend itself against specific attacks.
It's almost like we're not just building AI. We're teaching it how to think critically. And protect itself.
That's a great way to put it. It's not just about making AI more powerful, but also about making it more resilient. And to do that, we need a deep understanding of how it works at a fundamental level.
So maybe the solution to this whole adversarial attack problem isn't about inventing some fancy new algorithm. Maybe it's about going back to the basics of deep learning. And figuring out how to train these systems in a way that makes them inherently more secure.
That's a really insightful observation. It's about fundamentally rethinking how we approach AI security.
Okay, so we've talked about vulnerabilities, defenses, even the philosophy of AI. But this whole thing started with those researchers tricking AIs with handwritten digits. What are the real-world implications of all this beyond image recognition? And this has to go way deeper, right?
You're absolutely right. This research might have focused on images, but the implications are much broader. Deep learning is being used everywhere, from voice assistants to medical diagnoses to self-driving cars.
Okay, now I'm getting a little nervous. Give me some real-world examples. Paint me a picture of what could go wrong if these systems are vulnerable.
Well, imagine a self-driving car that misinterprets a stop sign as a speed limit sign because of a carefully crafted sticker.
Oh, wow.
Or a voice assistant that's tricked into authorizing a fraudulent transaction.
So it's not just about annoying glitches. We're talking about potentially life-threatening situations.
Exactly. And then there are the less dramatic but equally concerning implications for things like social media algorithms. Imagine someone manipulating a system to spread misinformation or suppress certain viewpoints.
Okay, now I'm officially freaked out. So what's the solution? Is this just a tech problem waiting to be solved, or is it something bigger?
It's both. Really, technically, we need to develop better defenses. But just as importantly, we need to have a serious conversation about ethics and responsibility in AI development.
It's like we're unleashing this incredibly powerful force into the world. But we're still figuring out how to control it.
That's a great way to put it. And the stakes are only getting higher as AI becomes more sophisticated and integrated into our lives.
You know, this whole conversation has been really eye-opening.
Yeah, it's fascinating stuff.
It's made me realize just how much we still don't understand about AI and its potential impact on the world.
I agree, and I think that's an important message for everyone to hear. We need to approach AI with a sense of humility and caution, recognizing that it's not a magic solution, but a powerful tool that needs to be used responsibly.
We've covered a lot of ground today, but I feel like we've only scratched the surface.
Oh, absolutely. There's so much more to explore in the world of adversarial machine learning. And it's a field that's evolving rapidly.
But for now, we'll have to leave it there. Thank you so much for taking us on this deep dive.
It's been my pleasure.
It's been both fascinating and a little bit terrifying.
And I'm glad we could delve into this important topic together. It's not always easy to face these unsettling truths, but it's crucial that we do.
And for you listening, thanks for joining us on this journey.
Yes, thank you.
We hope you found it as thought-provoking as we did.
And we encourage you to continue exploring this fascinating and important field. The more we understand about capabilities and limitations of AI, the better equipped we'll be to navigate the future that lies ahead. Thinking about the consequences of these attacks, it's not just about the immediate harm they can cause.
Right. We talked about self-driving cars and voice assistants being tricked, but it feels like there's a bigger picture here.
It's about trust. If people see AI as unreliable or easily manipulated,
Right.
who's going to want to use it?
Right. Yeah.
It could have a huge impact on the development of the entire field.
So it's not just about stopping individual attacks.
Right.
We need to maintain public confidence in AI as a whole.
Yeah.
Otherwise, no one's going to want to invest in it or use it in their daily lives.
Exactly. Imagine if every time you used a self-driving car,
Yeah.
you were worried about someone hacking the stop signs.
Oh, yeah.
The whole industry would grind to a halt.
Okay.
Yeah.
Yeah, I can see that. So how do we build that trust? Is it just about making AI systems more secure, or is there more to it?
Security is a huge part of it, no doubt.
Right.
But we also need transparency and accountability.
Okay.
People need to understand how these systems work and know that there are mechanisms in place to address vulnerabilities.
So we need to be open about the limitations of AI
Yes.
and have clear ways to hold people responsible when things go wrong.
Absolutely. It's like any new technology.
Yeah.
There will be bumps along the road. But if we try to sweep those bumps under the rug,
Right.
people will lose faith.
So we need to be honest about the risks,
Yes.
but also emphasize the potential benefits.
Right. AI has the power to solve some of the world's biggest challenges, but we need to be thoughtful and responsible in how we develop and deploy it.
This whole conversation reminds me of that saying, with great power comes great responsibility.
Mm-hmm.
And it feels like we're just starting to grapple with the responsibility part.
That's a great point. It's not enough to just focus on making AI more powerful.
Right.
We need to be asking ourselves tough questions about how it's being used and what safeguards need to be in place.
It feels like this goes beyond the technical aspects of AI and touches on some really fundamental questions about our values as a society.
You're absolutely right. What kind of world do we want to create with this technology?
Yeah.
How do we ensure that it's used for good and not for harm?
Right.
These are questions that we all need to be thinking about. It's a lot to consider.
Yeah.
But I think that's what makes this such a fascinating and important topic.
Yeah.
We're not just talking about algorithms and data sets. We're talking about the future of humanity.
I couldn't agree more. And it's a conversation that needs to involve everyone, not just the engineers and scientists.
Right, because at the end of the day, AI is a tool that's meant to serve us, not the other way around.
Absolutely.
We need to make sure that we're the ones in control.
Well said, and I think that's a great takeaway for our listeners.
Yes.
We need to be informed, engaged, and ask critical questions about the development and use of AI.
Okay, so to sum it all up, we dove into the world of adversarial machine learning.
Yes.
Explored how even the most advanced AI systems have vulnerabilities, and talked about ways to defend against these attacks. But beyond the technical stuff, we also touched on the bigger picture, the societal and ethical implications of this technology.
We did.
We talked about the importance of trust, transparency, and responsibility in AI development.
And how these questions are going to become even more critical as AI becomes increasingly integrated into our lives.
Absolutely.
It's definitely been a mind-bending journey. Thank you so much for sharing your expertise and insights with us.
It's been my pleasure. This is a topic I'm incredibly passionate about, and I hope our conversation has inspired you to learn more.
And for you listening, thanks for joining us on this deep dive. We hope you found it informative, thought-provoking, and maybe even a little bit unsettling.
Because sometimes a little bit of healthy unease is what we need to stay vigilant and ensure that we're shaping the future of AI in a way that benefits all of humanity.
Well said. Until next time, stay curious, stay informed, and stay engaged in this crucial conversation about the future of AI.